Hello. So in this problem, we're going to take a look at how to uh, do a problem using parts by mass. So the problem reads that a water sample contains the pollutant chlorobenzene with a concentration of 15 parts per billion by mass. What volume of this water contains 5.00 times 10 to the power 2 milligrams of chlorobenzene? And they've also given you the density of the solution. All right, so the first thing you need to do is understand how to start off with parts per mass, because that's what's given to us. So we're going to write that down. Given is 15 parts per billion of chlorobenzene. All right, so now the solution, what we need to understand is we have a solution, and in the solution, the solute out here, let me write that a little properly. The solute is the chlorobenzene. All right, so if the solute is the chlorobenzene, then if we think about parts per billion, what we're saying is that if, for example, we're measuring in grams, then 15 grams of solute is contained in a billion, which is 10 to the power 9 grams of solution. Okay, so now once we have this, we need to understand that if we take this solution basically and we reduce the quantity of the solution, at some point in time we're going to get 5.00 times 10 to the power 2 milligrams of chlorobenzene. Now, if you actually convert this to grams, you'll have to actually multiply the 10 to the 2, this whole thing, with 10 to the power negative 3. Okay, and I'll kind of show you how to do it in a few minutes, but basically it's a very small quantity. This ends up being a very small quantity. All right, so essentially we have a large quantity. We're saying that if we take a very small amount, a much smaller amount of the solute, how much solution is there? So the way you can set it up is you can just set it up as an equality where the amount of solution which you're trying to calculate is x. We put that at the bottom, and the amount of solute is already given to you out here. So what we're saying is if we take this solution and we reduce the quantity to this amount, then that should be the amount of solution, which is x. So we're going to solve for that x, okay? Now, before you can solve for x, we have to change milligrams into grams. So to change milligrams into grams, we need to understand, let me just use a different color out here. We need to understand, and I'll write that out here, that 10 to the power 3 milligrams is equal to 1 gram. So if we change that into a fraction to multiply with this term, then that becomes 1 gram over 10 to the power 3 milligrams. Okay, so let's go ahead and multiply that. So times 1 gram over 10 to the power 3 milligrams. And when we do that, what you'll see is that the milligrams cancel out, and then we can kind of simplify that to give us basically this ends up being 5.00 times 10 to the negative 1 grams over x. And the left side, we'll just drop all the grams to make it simple. We call that 15 over 10 to the power 9. And if you think about why we drop the grams, because those units kind of cancel out. All right. So once we have that, then we're solving for x. So now this solution for x is going to be, it might be a little more complicated than we are little more complicated for us because x is kind of at the bottom out here. So my recommendation would be to kind of flip the equation on its head. So if you flip it on its head, you get x over 5.00 times 10 to the negative 1 is equal to 10 to the power 9 over 15. And once you have that, then we can multiply both sides with 5.00 times 10 to the negative 1 to solve for x. So those two cancel out, and then we get x. If we kind of do the math out here, we get x is equal to 0.03333, repeating, basically continues, times 10 to the power 9 grams. All right, so once we have that, now the next job is to convert that grams to milliliters, because we're trying to solve for the volume of this water. So out here, you have to use the density of water, which says that the density is 1 gram per ml. So you can directly use that relationship to say that x is equal to 0.03333 times 10 to the power 9, milliliters. Okay, so once you have the milliliters out here, the next thing we want to do is we want to convert the milliliters into liters. For that, we have to use the relationship. Put that in green out here. The relationship is 10 to the power 3 ml is equal to 1 liter. And the fraction we're going to use to multiply it with is going to be 1 liter over 10 to the power 3 ml. So if you multiply this entire thing with 1 liter over 10 to the power 3 ml, that gives us x is equal to 0.03333 times 10 to the power 6 liters. And if we want to change this into scientific notation, we can move the decimal 2 places to the right. So that gives us 3.333, repeating basically, times 10 to the power 4 liters. And now at this point in time, we want to watch for significant figures. So if you go to the top of the problem, it says out here, they give you 15 ppb. So that's 2 significant figures. Notice carefully, there's 3 and 3 out here. We're not going to worry about those. We're going to go with the least number of significant figures because all we did was multiplication and division. So the correct answer is going to be 3.3 times 10 to the power 4 liters. I hope that made sense. Thank you for watching.